In this video, we will show you how to solve Leetcode problem 23, merge K sorted lists. First, let's look at an example. Given three lists L1, L2, L3, they're all sorted. We want to merge them together into one big sorted list as shown at the bottom of this screen. There are many different solutions, but in this video, we will show you three solutions. One, we compare each head of the list one by one. And then solution 2 will optimize the solution 1 by using a priority queue. At the end, we'll show another solution that use divide and conquer algorithm. Let's see the solution 1. For the solution 1, we compare the head of each list one by one. As shown in this red rectangle, 1, 1, 3 are the heads of the list. We don't have to compare the other elements of the list because each list is sorted. We only have to compare the heads. So if we compare the heads, pick the minimum, in this case it's 1, and then move this picked minimum node to the merged list. After that, we move the head of the L1 to the next node, that'll be 4. And then we repeat the process. So in this case, in the next iteration, the minimum node will be 1. We move it to the merged list, and then among the remaining lists, we pick the minimum head, move it to the merged list, and repeat the process until everything merge into this one big list. So now let's look at the implementation. On the top of the screen, it's given the list node as integer. Each node has integer value, and the refers to the next node. This merge k list function, we start with checking if the list is null or empty. In this case, we return null. Because we're looking for a minimum, min is initialized to max. And then index is the index of the minimum head in the list array. So that we start with -1, and then we compare the first element, that index 0. So in this loop, we loop through every single list. If this list is null, we skip. Otherwise, we compare the value at the head node to the current minimum value. If the head node is smaller than the current minimum value, we record the index, and we also record that current minimum value. After this loop, we will find the minimum node among those heads of those given k lists. Next step, we will put this minimum node to the merged list. In this case, it's t. So the picked minimum node 1 is added to the merged list. After that, we recursively repeat the process. For example, once we pick this minimum node, then we have to repeat the process for the remaining lists L1 and L2, L3. It's shown in the bubble here. That is this function. At the end, we will return t as a merged list. Now let's look at the complexity. We have a k lists, and then picking a minimum node from the k list, we have to compare with each list, and then we have to do this for each element of the list n. So the complexity will be O, K, N, where k is the number of lists, and is the number of elements in the list. The space complexity, in one iteration, there is a constant or O1 space is needed, but because of the recursive call, we need ON auxiliary space. If you submit to the Leetcode, it passes all the tests, but it says this code is faster than 7% of Aussie people. This is correct, but slow. We are right here. Means we're only better than 7% people. Anytime you find yourself at the bottom 10%, that is not good. So this is not acceptable. We want to improve this code. That'll be the next. Solution 2. For this solution, when you compare the heads of each list, we don't want to compare them in a linear order. We want to add them to a priority queue. So we first, all the head nodes is shown here in the red rectangle, we add them to a priority queue as shown at the right side. And then we remove the minimum from the priority queue. Every time when a node is removed, we add the next node of that node to the priority queue. For example, in this case, first time we add the heads 1, 1, 3 to the priority queue. When we remove this head node 1, the next node 4 will be added to the priority queue. That will be this case. We removed 1 from the priority queue, and the next node of 1, 4, is added to the priority queue. Definitely this one was the original left node in the priority queue. Now it moved to the top or become the minimum. So we repeat this process until everything again is added to the merged list. Okay. With this improvement, the comparing the heads of all lists became from OK to a log K, because adding an item to a priority queue is log K in this case. Now let's look at the solution. So again, if the list is null or empty, we return. So we add a priority queue of nodes, and then we create a dummy node, and then this is a moving node. And so let's add all the heads of the list to the priority queue. Right now, if the priority queue is not empty, we remove a node. That'll be the current node. That'll be the current minimum node. So this merged list, right? Merged list will point to this current node, and then move the parent node to the next, and then anything that we removed from the queue, we add it next to the queue. So in this case, we removed 1 here from the previous example, and we added 4 to the priority queue, right? So at the end, we will return the head next, because head is a dummy node, right? Head is a dummy node in this case. We'll return the next. That will be the merged list, okay? So with this improvement, if you submit this code to the Leetcode, it says we're faster than 81% of people. So this is definitely much better. So now let's see another solution. For solution 3, we only use divide and conquer algorithm. We want to convert this merge k list problem into a merge 2 list problem, for which we sort each 2 lists, create a bigger list, and then sort those bigger lists again, each 2 bigger lists together recursively, and eventually we create this merge list. With this, we don't have to visit nodes repeatedly, and it could be much faster. Now let's look at the implementation. So merge k list will send us list, and then start and end index to the recursive merge k list function. Merge k list, the recursive merge k list, I will split this list until it becomes a single list L1 and a single list L2. And then eventually use a merge 2 list algorithm from the Leetcode problem 21 to merge these 2 lists together. And then another recursion will merge the other 2 lists, and then each of them will generate a bigger list. And now the merge 2 list algorithm again will merge them together into a bigger merged list, and eventually we will have this big merged list at the end, and this function will return that. So definitely this algorithm is shorter and more elegant, but you have to understand how the divide and conquer works. For this solution, we use a merge 2 list from Leetcode problem 21. We don't want to explain that solution again here. So there are multiple solutions, recursive or iterative. Please check it out. But here we'll give you one iterative solution. Please go back and check the Leetcode problem 21. So if you submit this code, it says it's faster than 98% of other submissions. I guess this is fast enough. So in this video, we gave you 3 different solutions for the Leetcode problem 23. We'll come back with more problems soon. Thank you. Bye-bye.